Right, so we now move on to solving trig equations with the tangent function. And in this case, we just need to remember it's the same procedure as solving for your sine or your cosine. So it's always going to be the same thing. So let's start off right away with an example. We have our function, negative 2 tan pi over 2 times x plus 1 plus 1. And we want to find that 0 of the function. We want to know when that function will be equal to 0. So the first step that I always had told you whenever we are solving a type of equation like this is to find your period. So your period would be 2 in this case. Now how did I get that? Well, period is equal to pi divided by the absolute value of b. Now why pi? Well, we said that the period for the basic tan function would be pi. So whenever you're calculating the period, it's going to be pi divided by the absolute value of b. So we get 2. We then rewrite our equation because we're solving it in terms of the 0. So we got to bring over this 1, and then we would divide by this negative 2. However, usually 1 over 2 or 0.5 is a remarkable angle, but that's only for sine and cosine. We're now dealing with the tangent function. So we don't know what the remarkable angle is in terms of 0.5 for tangent. So we need to take the inverse tan. And we get a value of 0.46. Now ask ourselves, how many times do we have a 0 in our tangent function? Well, if you remember what the graph of tangent looked like, there was only one 0. It only happened once, which means you're only solving for one answer. There's going to be none of this pi minus theta or 2 pi minus theta like we saw for sine and cosine respectively. We're just going to be solving for this angle. And in this case, our angle would be 0.46. Therefore, we now move on and say, all right, well, your answer is therefore going to be 0.46 is equal to pi over 2 times x plus 1. And we solve for the value of x. So once you divide everything by pi over 2, we get an answer of 0.29, which is equal to x plus 1. You bring over that positive 1, it becomes negative, so we get an answer of negative 0.71 as x. However, we want to find all the values of x that will make our equation equal to 0. So in this case, we need to add our 2n, because 2 is your period in this case, and the n represents the amount of turns that you are doing. So therefore, our solution set will be negative 0.71 plus 2n. All right, now we've done graphing, we've done solving trig equations in terms of tangent. We now need to do the last thing, which the basic point of all this is to find the rule now. So we've done the solving, so this is going to be used to find the rule. So your first step is going to be to locate the inflection point, that h and k. So if we don't remember what inflection point is, it's that point where there's a change in direction in your tangent function. So you could have been concave down or concave up, and then you just flipped over. So again, if you don't remember what that is, we'll see it when we get to our example. Step 2 is to find the value of your b. Step 3, substitute the b, your h and the k, and the point on the curve, because that's your x and your y, to solve for a. And the last step is to deduce the rule. So, finding the rule is not that difficult. It's going to be a lot of algebra, but the problem with this is that there's going to be algebra in terms of trigonometry. So, this is our function. This is our rule that we're going to be trying to determine. Now, if we look at our graph, there's either 0 and 2 or 5 and 1 that is going to be the inflection point. So what does it mean to be an inflection point? Well, inflection point is going to be that change in direction. So when you were concave up and down, then you're concave down. And the only point that represents that would be this 5, 1, because at one side, you are facing upwards, and at the other side you are now facing downwards. So 5, 1 would be your inflection point, that would be your h and k. From there, we were told that we need to solve for the b. So b is going to be pi over 4 in this case. Now, how did I get pi over 4? Well, the absolute value of b is going to be pi divided by your period. And since my period is 4, I get a value of pi over 4. Now, I need to determine if it's positive or negative. Now, in this case, because I am decreasing, I know that a times b is going to be negative. So what I've done is I've put b as a negative number in this case. So I should get an answer that is positive for my a. So this is what my function looks like. I also know a point. I know the point 0 and 2. So I can make that substitution. And now we just clean this up a little bit. So we're going to put that 1 on the other side. So this plus 1 now becomes minus 1. So we get 2 minus 1, which is 1. We get negative 5 times negative pi over 4, which becomes 5 pi over 4. Now this is where we need to remember how to do these types of calculations, which were the exact value calculations using our trig circle. Because you don't have tan on your trig circle, you're going to have to remember what tan of 5 pi over 4 is. So you can switch this into sine of 5 pi over 4 divided by cosine of 5 pi over 4, whatever you want. But the easier way of doing this is to say, okay, well, what's my reference? It's going to be 45 degrees. And at 45 degrees, the tangent is always going to be 1. Now I need to determine, am I in quadrant 1, 2, 3, 4? What's the value? Am I positive 1 or negative 1? And the tangent of 5 pi over 4 would be in quadrant 3, where both sine and cosine are negative, so tangent will be positive. So I get a value of positive 1. So in other words, a is going to be 1. So I put all this information together, and I get y is equal to tan of negative pi over 4 times x minus 5 plus 1.